Hi, everyone. I'm going to be addressing feedback from Wednesday's lecture here, which was our introduction to solubility equilibria and KSP. So I had one question: is KSP only for solubility, even though it has the same equation for the equilibrium constant? Yeah, so let me address your question. You're right. KSP, it is an equilibrium constant. It just happens to specifically describe an equilibrium of a solid going into solution. So any reaction that you can conceptualize of a solid going into solution, from solid to aqueous, that is described by an equilibrium process. That you can write a law of mass action for it, and the equilibrium constant for such a reaction we call KSP. So KSP, yeah, you're right. It is specifically for describing solubility, something going from from solid into solution, but it is also an equilibrium constant. Is everything soluble just what we count as insoluble? Just has a very, very low KSP. Yeah, I would say that that's accurate. You can say that in theory everything is soluble. Some amount of any substance will dissolve in water or some other solvent. It might be a very, 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 very small amount, in which case we could say that the KSP for that salt or solute is absurdly low, is very, very small. On the contrary to that, I had another question, which would mean if your KSP is very, very large, much larger than 1, would that mean that the substance is highly soluble? Yeah, that's exactly right, that a soluble substance has a very, very large KSP. Will we need to refamiliarize ourselves with the solubility rules? Do we need to memorize them? You don't need to memorize solubility rules. And at least in lecture, I don't think that there is any need within lecture to explicitly go back over or go over solubility rules in excessive depth. I would say take a look at them. If you've learned them and been assessed on them before, it's kind of like riding a bike. You'll pick it up really, really quickly. I would say that perhaps since we are talking about solubility and predicting which things should or should not precipitate, there might be some value in your own time, glancing back over the rules. But in general, no. You don't need to familiarize yourself with deciding whether classifying a substance as insoluble or soluble. We have moved beyond that basic categorizing scheme. Now we're going to work with the assertion that everything is to some degree soluble, and the degree of solubility is given by either its solubility, mass in moles per liter of solution, or we'll express it in terms of solubility products, KSPs. So I would say it might be worth 15 minutes glance through the solubility rules, but no, you don't need to worry about being tested on them specifically. Can you discuss the hard water problem? Why do you mix solutions 2 and 3? Okay, so the solubility or the hard water problem was saying how do you precipitate out calcium ions? Meaning that you wanted to convert these from some aqueous state into some solid compound. So the way to think about this is the question gave you 2 hints. One was about the KSP for calcium carbonate, and one about the KSP of calcium phosphate. So calcium carbonate, the reverse of its KSP reaction would be this. This is going from 2 aqueous reactants to calcium carbonate as a solid. And then we also said that, okay, we were told about the KSP of calcium phosphate. So this should be 2 phosphates and 3 calciums react and give me a calcium 3 phosphate as a solid. And we're told that the KSP we are told that the KSP of calcium phosphate is much smaller than the KSP of calcium carbonate. That was a bit of information we were given. So I've written these reactions in the reverse of how it should be written for a KSP. KSP should describe the solid going into solution. These reactions are just reversed. So I could say the K for this reaction is equal to 1 over its KSP, and the K for this reaction is equal to 1 over the KSP. So in that case, the one with a smaller KSP of these reactions, the one that has the smaller KSP is going to have the larger K. It's going to have the larger equilibrium constant. So since this one has a smaller KSP, it means that the equilibrium constant for this reaction is much larger, meaning that this forward reaction is more favorable than this forward reaction. So the best way to remove the calcium ions from solution is to use phosphate ions. So we definitely will want to try and produce calcium phosphate. We weren't given a phosphate solution to work with. What we were given was a buffer solution of sodium dihydrogen phosphate and sodium monohydrogen phosphate. Now these guys are the conjugate bases, and they're the conjugate bases, but they are also, how should I say this? They are polyprotic acids. They represent after phosphoric acid has donated one of its protons, it produces H2PO4 minus. This guy can donate another proton to get you HPO4 2 minus, and then this guy can donate a third proton that should be just 2 minus, and get the phosphate ion, which is what we're looking for. So the solution only contains these two ions, or rather that buffer solution only contains these two ions. So if we want to produce phosphate ions, which is what we want to get so that we can add it to our hard water, which contains calcium, get them out, we need to find some way of removing these extra protons, these extra hydrogens, to get to a phosphate ion. So the next step, or the suggestion here, is to use solution 2. So this was solution 3. Solution 2 was a solution of sodium hydroxide. So this is a base. The base will accept protons from other chemical species. So if you add the base to this sodium phosphate solution, you'll take the proton off of that phosphate, you'll take all the protons off of this phosphate molecule, and you'll be left with the actual PO4 3 minus molecule. That's after all the protons have been removed. And then you will have a solution predominantly of phosphate ions. That solution you can mix with your hard water and precipitate out calcium phosphate. Okay, so if you have further questions about that, I would be very happy to discuss them in office hours, but I hope that clarifies things for people. So I got a few comments saying that people liked the real-world questions, that it gave people a chance to actually answer them on their own. I always like to try to do that, and I will continue to try to find good questions that fit into that scenario, or that fit those criteria. I got one request for me to update the reading schedule. I recognize I have not updated that in a little bit, and we are a couple of lectures behind that, so it does need to be updated. I will be doing that very soon, and I'll have that posted. Otherwise, that's it for today, for this feedback video. So otherwise, yeah, I will see everybody on Monday. I hope you all have a good weekend. Take care. Oh, yeah, that's it. All right, have a good weekend.